I'm Brad Ashley. I'm the Director of Business Development here at Solve3D.
And I'm Scott Campbell. I'm the CEO here at Solve3D. And Brad, we're into video 2 of the object classification using deep learning on LiDAR. Boy, that's a mouthful. What's this video going to be about?
Yeah, so video 1 was covering the training data, and here in video 2, we're going to be actually training a model and going through how that works. Before we get too far into it, though, Scott, we did have some questions that came in, and I thought we should do a quick recap on the training data itself.
Yeah, that's probably a good idea. So first of all, let's talk about that overall workflow. It's a 3-stage workflow. Video 1 was about step number 1, which was preparing the data and making sure you had really good training and validation data. Brad, I think you might have a little example here of LiDAR-specific data that we can look at and talk about.
Yeah, here we have an example where we have some points that are run through the data that are unclassified. So if we keep this data, in a small amount, it probably won't be an issue. But if we've got, as you're seeing on the screen, a large amount of unclassified points that are running through the ground data, you're going to have issues with that ground classification. And so we recommend that you deal with this unclassified data. Very similarly, if you had data that's incorrectly classified, maybe you have a building that's classified as vegetation, or you've got a tree that's classified as a building, you'd want to clean that up. And if you've got probably 10 or 15% of your data set in that case, in that way, it probably won't be an issue. But when you get into that 30, 40, 50% of your data being incorrectly or unclassified, it's going to cause some major issues.
Yeah, I think of it like teaching or training a person. The training data is meant to give example of, this is what I want you to recognize. This is what I want you to recognize. This is good. This is good. This is good. But if you're actually giving the model training data that is, well, this is good, but it's actually bad, then it's really confusing. It'd be confusing for a person. So it's not a black and white kind of thing. It's a bit of a grayscale.
Yeah, that's a good example there, Scott. Now that we have our training data ready and prepared, and we start to go into the training of the model, I did want to mention that we recommend that the data be split into 2. And in this case, what we're recommending, as you can see on the screen, is a 66% split and a 33% split. So 2/3 of the data ready for training and 1/3 of the data ready for evaluation. And the reason for that is that as we go through the training here today, you're going to see that the training data tests, and then it goes and tests the evaluation data equally. And so it's back and forth going to see how the accuracy and the loss of both of those data sets are. So that's why we recommend, again, splitting that data before you start running it through the algorithms.
I think of Brad as like the validation or the evaluation data is like a pop quiz in school. So, the training data, you're using that, you're doing your exercises, and the teacher comes along and gives you a pop quiz. That's what the validation data is for. That's the data for that pop quiz. So the learning algorithm actually has a chance to test itself to see how it's doing, to know whether it's getting better or worse. And I think we'll see that a little bit later when we talk about the tensor boards.
Yeah, great. Scott, in the last video, we talked about why did we choose deep learning, and we went through, the reasons that we saw. Now that we're into the training, can you explain a little bit about the algorithms that we're specifically using?
Yeah, so the algorithms are what are used to create the trained model that you'll use for classification. In this case, we went through and we looked at what was available out there in industry, and we settled on PointNet from Stanford University. They really were a pioneer in applying these techniques to point sets or point clouds. And the latest version of their work is PointNet++. So that is at the heart of our framework, and it's a really, really good framework. But it does drive something really important. This framework requires some significant computing power. So maybe we'll just flash up here, Brad, the minimum system requirements. And when we say minimum, we really mean minimum. You do not want to try to run this unless you have a computing environment that has this sort of requirements or specifications. And this is listed out in the handbook as well as the user guide. So you're going to want to take a hard, cold look at your computing environment about what you want to run this framework on before you actually go to run it. In fact, we would recommend this set of requirements or this set of specifications for your computing environment in order to have something that's it's not going to take 20 days in order to run. Okay, we're actually going to get Kevin to walk us through this training piece and not Brad. So Kevin, we've got Engine open here and I want to run the training. So come down to Object Classification Module and then down to Point Cloud Training. This pops up. Now I guess I have to set the folders. So.
That's right. So yeah, in the workshop data, there's going to be a whole bunch of folders. One being training data, the training data,
yeah,
and validation data. So the difference being training data is what the algorithm is going to learn on, and the validation data is what the algorithm or the model is going to test how well it learned against. And you need to select an output folder. Yeah, so you can select the My Results folder there. And then pre-trained model, we're doing this model from scratch, so there's no pre-trained model. We'll leave that blank. Batch size, we're going to stick with the defaults for this workshop. You can see our user guide for kind of more additional information, but the default setting should work for most people as long as you meet the minimum requirements. If you do have a beefier GPU or faster computer, you might want to try some of the larger values here. Points count, again, that will select the default of 4096. Classes count, this is based off the number of classifications in your data. This workshop data has 8 classes, so we're going to select 8. Epochs, or number of iterations, is how many times the algorithm's going to learn and it's kind of cycle through things and learn from the data. For the workshop, we're just going to stick with 512. However, I do recommend that if you have time to wait and maybe you're trying this later with your own data, definitely try larger numbers there and let it learn some more. And then units, this data is in meters, so we're going to select meters.
Okay.
We'll just
what about these? I was going to ask you about these advanced parameters.
Yeah, so these are explained in our user guide, but just at a high level, most of these control how or what types of data or attributes within the point cloud, what attributes the model will learn from. So say, for example, if you have a colorized point cloud and your water is always blue and your trees are always green, and your source data has some RGB values to it, then definitely you might want to use RGB on. For the purpose of this workshop, we're just going to leave everything at default. The only thing I may recommend, that model title, I may recommend typing in a name here. This is really good for version control, especially if you're running this a couple of times for a whole bunch of different data sets. You don't want to get confused. So put some meaningful title in there just to help find it later if you're looking for it.
Okay, so now I come down to execute. I hit execute workflow, and we started on the process. I should point out that if you're running this for the first time, Engine may download a bunch of resources that it needs to run in order to get set up. So that may add an extra couple of minutes. But once you do download those resources, it doesn't need to download them again. And now Engine is going through and getting set up.
Yep. So it's currently analyzing all that training data and the validation data just to make sure. It has 8 classes. It has values that are some of the attributes that you may have selected. Just making sure they're all uniform and consistent across the data sets. And then after this step, it will actually start doing the learning, and you should see a TensorBoard or a TensorFlow, basically a TensorBoard window pop up that has a whole bunch of graphs that will show you how well it's learning and the accuracy rate as it goes through each iteration. So it takes a few seconds or a minute or two to load up here.
There it is.
Yeah, here we go.
Okay.
So a couple things to mention on this page. So by default, since the process just started, there's not much to show. So you'll have to wait 5 or 10 iterations to start seeing some values here. The most important graphs here are the accuracy graphs at the top, those 2 evaluation and training graphs. They are going to be what you can use as a kind of basis or guideline of how accurate in terms of percentage the model is learning. And since it just started, we don't see any data, but once we get something here, there's those three little buttons below the graph, and periodically I recommend clicking on the third button there. That will resize the graph to, basically change the axis values, the min and max values, to whatever the range is of the values in the model. So
Here we
here we go. So we got 5 iterations done. So Scott, if you want to click that
I'll just
little
click
icon.
the little icon, and you can see that, of course, it adjusts the scale.
That's right. So
Yeah.
we're only, like what we can see here, we're only at 5 or 6 iterations, and we're around 41% accurate in terms of the evaluation. And if you look at the training data, we're about 60%. So let this run, let it go through the iterations, and you can monitor the progress.
Okay, well, let's fast forward to the end and have a look at the results.
Sounds good.
This error will pop up at the end of your training because TensorBoard thinks that there's actually more training to be done, but your training is finished. So this typically happens if you walk away from Engine and let the training finish, like most of us are going to do. So that's where this error is going to come from. So when you're done your training, you're definitely going to want to check the TensorBoard graphs to see how your model did. To do that, go back into Engine, open up the Object Classification module, come down to View Model Stats, click on it, and it will open up the function. There's only one input for the function, and that's to tell Engine where your model sits. In this case, it'll be in My Results. And I've done 2 runs of this, so I will pick one of them, the one that I want to check. Select the folder, hit Execute, red button, and then execute the workflow, and that will open up TensorBoard, which will then go through and load in the data, load in the graphs. It'll take a few seconds, and then it'll pop open, and you can see the results of the training and then evaluate what you need to do in terms of more training, different data, or simply accept the results as they are and use that model.
And Scott, what are you thinking about the saving of these models?
It's a really good practice in software, but certainly in this case as well, in deep learning, to have version control on the model, which is to say every time you save it, give it a version number, and in the maybe even in the title of what it is, make a nuance. So if you were doing this for the fire hydrants that we talked about in video 1, you might say, Chicago fire hydrants version 1. And if you then go back to try to update the model with fire hydrants from Paris, you could say Chicago/Paris fire hydrants model 2. And that way, if you've got that version control and you have different versions saved, you can actually revert. So if you find that, oh yeah, listen, the model did not train very well, my testing is disastrous, you can actually revert to version 1 of your model and not to be too fussed about it.
Yeah, that's a great point, Scott. And here we'll pop up the key point summary for this video, which is that version control. If you feed it the wrong data, if you feed it data that you thought was really well classified but wasn't, and things start to go sideways, being able to go back to that previous version is critical, both for the model itself, but also for the timeline of your project and ensuring that you can stay on top of that stuff.
Yeah, absolutely true that. So if that's the key point summary, Brad, then I'm guessing that's the end of this video. So what are the next steps here?
Yeah, that is. This is the end of video 2. We now recommend that you take that data that was sent over, the sample data, and run it through a training algorithm of your own. See if you can get similar results. Look at the tensor boards that you saw here in the video and see if you're getting similar accuracy and loss on the results that you get. Once you've done that, we'll do a quick check-in with you probably in the coming week to see how those results went. And then we're going to recommend that you move on to video 3, which will be the classification of the unclassified data sets.
All right. Well, Brad, I guess I'll see you in video 3.
All right. Thanks, Scott.